Welcome to another episode of Amazon Spanners. Uh, Change of location tonight. We're talking about 3D printers, so I'm gonna have to do this one in the office. Hope you enjoy. Okay, so 3D printers and classic cars. Old meets new. Is it a worthwhile thing? Is it something that could work? Is it something that will work? Yes, it will work. There are a couple of pitfalls. And that's what this episode is all about, is to answer a couple of those questions. Get the facts straight, get the right information out. I believe there is a misperception with what 3D printing is, or how 3D printing works, and how the two combines. When I say the two, classic car restoration and 3D printers, how the two get together. So, can you print anything with a 3D printer? Absolutely. Can you download anything and load it into a 3D printer? Unfortunately not. Can anyone run a 3D printer? Yes. On condition. It's not a device that you pull out of a box, plonk down on a table, connect to your PC, and off you go. It's a little bit more involved in that. Most 3D printers, like both the printers behind me, comes in a knockdown kit form, so when you get it, there is some assembly required. Nothing major, nothing too technical. The instructions that comes with the machines are brilliant, very self-explanatory. The information is clear and concise, so you can very easily set up the printer. The time-consuming part in owning a 3D printer is not putting it together. Where the time consumption with 3D printers comes in is getting to know how the 3D printer works. When I say that, you are going to lose probably about 90% of your prints in your first couple of months of printing, or first couple of days of printing. The reason for that is, and it's stuff that you don't know about when you buy the printer: bed adhesion, printing temperatures, printing materials, how to print with those materials, fine-tuning the machines, bed leveling, all that type of stuff comes together. So I think before we get too involved into that, I think it's necessary just to explain to those that don't know 3D printers what a 3D printer is. Okay, so basically you've got a bed, or your print bed. Your print bed is physically that's the bed that your printer will print whatever you're printing at that point, will print onto that. What the printer bed is made out of depends on the manufacturer, and it depends on you. There's plenty of bed materials. These printers, which is the Ender 3V2, they come with a glass bed that's got a special coating over it that's supposed to enhance bed adhesion, which means the way the plastic or your product that you're printing sticks to the surface while it's printing. It's also a heated bed, which means the bed itself gets warm, which helps the plastic adhere. Personally, I love the printer, but that special coated glass plate never worked for me. I went and looked for information. I tried everything that was said: washing it with dish soap, washing it with hair care products, washing it with car wash or car soaps. I never could get that adhesion to work. Eventually what I did was to flip the glass over and print on the clean glass side with a mixture of sugar water. Spray a bit of sugar water on the glass, spread it around with a sponge, let it get tacky, and that's how I've been printing for probably the last 2 years maybe. I get decent print adhesion, I get decent prints out of it. It works. Okay. The next part that you'll look at is the hot end. So I know there's a camera in the way, but you've got The hot end basically is made up of a couple of components. So your first component is your nozzle. The nozzle is literally that. It's the bit where the plastic comes out of and then gets layered onto the print bed. Nozzles comes in different sizes and they come in different materials. So if you're going to be printing an abrasive plastic like a copper or a metal filled plastic, or a carbon fiber filled plastic, you're going to need a harder wearing print nozzle to do that. The bore of the nozzles, these are all 0.4 millimeters. The bigger the bore, the faster you print, but you lose quality and detail. The smaller the nozzle, the slower you print, but you get a better print quality, also known as resolution. Okay, now the nozzle screws into what's called the hot end. The hot end is usually an aluminium block with an element and a thermal sensor. Obviously the element warms up the aluminium block. The thermal sensor detects how hot the aluminium block is, so that you heat it up to the right temperature according to the material you're printing. After that you get what's called a heat break. It's literally a bit of a space between the hot end and the next step. The heat break is there to stop the heat from traveling up into the next section, which is the, for lack of a better term, I call it the cold end. It's basically a heat sink area where your plastic is fed into. You don't want the plastic to melt that high up because that's going to clog downstream. So that bit is kept cold so that your plastic runs through it and into the bottom hot end section. After the hot end assembly, you get the upper bit here, which is called the extruder. Your extruder does exactly that. It takes your plastic filament, which looks like that, and it feeds it into the hot end to be melted and then printed. There are many different types of hot ends or extruders. This is what they call a direct drive extruder, which means it feeds directly into the hot end. Standard, these machines come with what's called a Bowden tube extruder, which means the extruder sits in the back corner of the machine and it's got a pipe similar to this that feeds into the hot end. And the main reason or the difference between the two is, again, it's a term that you don't need to worry about now. If you ever do get into 3D printing, it's something that will bother you then. But as an amateur 3D printer, it's really not going to affect your life to a degree that it's an issue. But it's called retraction. So as your printer moves, when it stops printing to move to a certain spot or to move up in a layer or whatever the case may be, the filament retracts a little bit. Now, what some say happens, I personally never experienced it, is that the Bowden tube, where it connects into the hot end or onto the extruder, the way that it fits in is through normal pneumatic pipe fittings. So what happens is the Bowden tube eventually wears loose, so you get a little bit of sideways travel or forwards backwards travel on it, so you don't get a proper retraction. I personally can't say that it's ever been a problem for me. I can't say that it's the end of a world type situation. My reason for going or upgrading to a direct drive unit is because of the materials that I'm printing specifically on this machine now, which is the I think the time lapse died. So it's the material that I print, specifically flexible plastic, which is called TPU, if I remember correctly. So it's a flexible plastic that allows you to make soft elements. So O-rings or grommets, which I'm actually printing right now. Those grommets are actually for a project that we're finishing up tomorrow. I will be doing a video on that car when it's done, and keep out for that, because I will do unfortunately don't have a restoration video on it, but I will do a video on the final product of it, so keep an eye for that one. In any case, the direct drive extruders just works a little bit better with the flexible plastics. Okay, so as I started the video off, one of the misconceptions that I've got, or that I found with 3D printing and the general public out there, is that once you've got a 3D printer, you can download and print anything, nothing's impossible. It's not entirely true. With a 3D printer, you are absolutely correct. You can print anything you want, but there are limitations with what you can print. So, for instance, one of the biggest limitations with 3D printing is the strength of the prints. You can get unbelievably strong prints. However, to achieve an unbelievably strong print, you have to reduce or increase your infill material to a higher percentage, which means you're going to be using a lot more plastic, and your print is going to take a lot longer to print. A normal 50-40% infill is reasonably strong. It is reasonably structural, but not structural enough for 3D printing engine brackets. It's not strong enough to print door straps. It's not strong enough to print hard-working items. Like I said, you can go for 100% infill, print something solid, but just remember that the bigger you make the infill, the more difficult it is to get or the longer it's going to take to get a successful print. So that's something that you need to consider. The other major issue with 3D printers or 3D printed item strength, you need to remember that in a injection molded industry type situation, you've got a melted plastic that gets injected all at once into a form, and that shapes basically a solid block of plastic that's shaped into that form. With 3D printing, you print in layers. So you print your first layer. By the time your first layer is printed, that plastic has already settled. It's already cured. Then you start printing your next roll. So your next layer. So your next layer goes on top of hardened plastic, and that's how it builds up. So unfortunately, as you go up in layers, your print, those layers effectively become a weak spot. So for instance, if you print something that's going to have a sideways torsion, you preferably don't want to print in this direction. You'd rather want to print in this direction, so that you've got more torsional strength and rigidity to it. If you print in that direction, it's going to snap somewhere in between all those layers. So that's something that you also need to take into consideration. The other thing is, not everything and anything you need is available on the internet. So yes, there are a lot of things available for free. There's also a lot of things available that you have to purchase, but in a lot of cases you are going to end up in a situation where you're going to have to design your part yourself. And this is done through using, for instance, a CAD application, so a computer aided design application. So if you don't know CAD, or you don't know, at least have a pen and paper technical drawing background as a foundation, it might be a bit tricky to get into it, and it's something that you will have to learn, especially to start making your own components. For instance, I designed and printed these lens caps, which is the dome lens for the Triumph 2000 Mark II and for the GT6 and a couple of other cars. It's basically a direct replica of the original lens cap. I designed quite a few I printed quite a few of these already for customers. I've designed the actual dome light fitting with the little switch, where I used the original copper connections that was on the original switch. I actually used those on my 3D printed line. These are not available freely on the internet. I haven't uploaded them to the internet purely because this belongs as my IP under my business name. So there are stuff that I have uploaded. I'm not a complete outhouse in that regard, but certain things I do keep for myself. It is my business and I need to make an income out of it. Another example is wheel centers that I designed. These were for a client. He unfortunately lost one of the chrome caps from his mini light rims. We couldn't find replacements. I tried to make a few but didn't work out very nicely, so I made flat caps. I actually vinyl cutted the Triumph logo that's stuck in here, and this then replaced the original mini light center caps with these. So again, perfectly usable product, no issues with that. Another experiment that I'm busy with is the side indicators on the Triumph 2000 and 2500 Mark II and Mark 1 as well, I believe. So these will be the indicator lenses on the B pillar, next to the, basically between the two doors. Busy modeling out 3D printed lenses for those. This is still an experimental phase. That's the reason why I don't want to make everything available on the internet. These things takes a lot of time, a lot of prototyping, a lot of testing, and it is for my business. So that's the reason I don't make these available for free. Like I said, there are other things that I have shared for free on the internet, and there is a lot of things there. Specifically for the Triumph Spitfire, I managed to find quite a lot of things there, MGs as well. The point is, what I'm getting to is, if you're going to buy a 3D printer and think that you're going to plug it in and you're going to start printing car parts, no, there's a bit of a curve to it before you can get to it. The other major thing that you need to look at is your materials. So for instance, like I said, I'm printing these grommets right now, which is going on to the TR6 that we're finishing up on. These grommets are printed from what's called TPU. It is a flexible plastic. If you look in the background there, you'll see that thing over there. That is called a dryer, and I'll explain what that does in a bit. Certain plastics works better in cars than others. So for instance, the easiest plastic to work with, the plastic that you'll have the most success printing with, is for instance this one, which is called PLA. PLA is very forgiving, it works very easily, it basically it's the beginner's choice to get you going. Problem with PLA is it's not happy in high temperatures, and it's not happy with direct sunlight. It loses layer adhesion. So what I was saying earlier about the strength in the layers, it does lose layer adhesion, so it means it starts cracking, and because it doesn't hold temperature well, you do start getting warping in it. The one that I use probably most often in car builds is PETG, or PETG for short. It's got a better UV resistance ability. It is not as acceptable to high temperatures, and you can, and I have done quite a few components on cars with PETG, and I haven't had issues with any of them as yet. A lot of it is still trial, and a lot of it is still being practiced and tested, but so far I haven't had any issues. That is done with a see-through PETG or a clear PETG. Now you get the clear plastics, you get them in green, you get them in orange, you get them in blue, I think. So you can do lenses and stuff. Just remember, see if the camera will join up on it or focus in on it. You will have layer lines, and if you look in the front here, this one, because it's a dome, you need to print it with supports, which means you print on the inside. You can see those squares there. You literally print a support structure that grows with your print, and that support structure then breaks off after the print is finished. So you need to consider with lenses that you are going to have layer lines, you are going to have print marks, and you are going to have that type of thing going as well. Now it wants to focus when I don't need it anymore. So you are going to get that type of thing. So just remember, you're not with filament printing, you're not going to get a clear print without a lot of practice and a lot of trial and error and a lot of work. The next material that you're going to look at is ABS. ABS is really the pinnacle for automotive parts printing. It's strong, it lasts long, it's not susceptible to temperatures in any way, but it's also the most difficult filament to print with. Technically, if you're going to print ABS, you're going to have to print inside an enclosure where there's no outside airflow. You can't have any cold air brushing over your print, it will warp. The benefit of ABS is ABS is acceptable or gets melted by acetone, which means you can do what's called vapor smoothing. So vapor smoothing is basically a technique where you take a pot, you put your print on top of something that holds it away from the bottom of a pot. You take a tablespoon, I think it was, of acetone. You heat the pot with a lid on. The acetone vapors then obviously travel upwards. It adheres to the plastic, and the plastic floats out smooth, and you get a nice smooth finish where you don't see the layer lines. So that is a very big benefit to ABS. I haven't printed with ABS yet. I've done a couple of test runs with it, and it wasn't very successful. So I'm still learning ABS. So like I said, there's a learning curve to this thing, and it's something that you're going to have to work out for yourself, and whether it's worth getting into 3D. Basically, the biggest thing with 3D printing is you need a lot of patience to start off with. Once you get going, once your printer's up and running, once you're confident with the basics of a CAD application, once you're confident with your slicer application, once you've got all that, it's not that hard. And yes, you can do a lot. I mean, I've printed pipe fittings for air cleaners where your positive crank vent goes into the air cleaner. I've built 90-degree elbows for that, and our print is finished. So let's that cool down a little bit, and then it will release, and I'll show you what the flexible plastic works like. I've printed like I said, pipe fittings to mount PCVs into air cleaners. I've printed radio buttons, I've printed heater buttons, I've printed the dome lights, I'll try and get some photos and put the photos in the video as I'm talking. I've done custom gauge mounts or custom radio blanks with gauge pods in them for a GT6, for instance. I've done custom badges, I've done wheel centers. There's actually, I wonder where it is. I've got which is available on Thingiverse, is a original stylized Spitfire radio blanking. I've printed that, and I've had so far huge success, except with the radio blank, and that's the reason I mentioned that. Again, that was printed with PETG. If your car's not in the sun closed up for a long time, PETG is fine. The specific radio blank that I'm talking about is a car that I worked on, It was parked outside. The customer ordered the radio blank from me. I printed it and I put it in his car, and it looked brilliant. And while working on his car, it was parked outside with the windows up and the roof closed, and the radio blank actually warped quite a bit. So what you print also, the form that you print, the shape that you print, also dictates a bit what material you should and can use. So keep that into consideration as well. I wouldn't easily print engine components, although I have printed for my TR7. I printed a set of trumpets, or designed and printed a set of trumpets for the two carburetors as an experiment. That's been going now for a couple of months. I haven't seen any deterioration or plastic malfunction in that regard up to now. My theory is that the cold air flowing over it will keep it cold enough that the plastic wouldn't have issues. So far it looks good, but it's early days. I'm still testing. TPU prints, so the flexible plastic prints. There's one of the blanks that I've print or that I'm busy printing or printed. Come on, focus, buddy. Okay, well, you get the idea on that one. So there's another one. These were all designed in CAD or using CAD. So that would be a grommet for a wiring loom to go through. So there's that one. And then there's an actual blanking disc to close up a hole in the firewall. As I said, with TPU, it is a flexible plastic, so you can see it flexes and jumps right back into its shape again. So incredible useful stuff to have and to be able to print with. Biggest downfalls with 3D printing. Well, number one downfall, if you live in South Africa, load shedding. If you don't have backup power, or you can't have your printers running on a UPS, and you do need a sizable UPS, don't bother, unless you're printing small things. Load shedding is a major factor when it comes to what you can print. Most printers have a carry-on printing after power failure function. Unfortunately, that only works while your your print bed is warm. As soon as the print bed cools off, you do lose adhesion. So when the power comes back on and your printer resumes printing, you're going to end up with a mess because your print's going to have released from the print bed. So it's a nice feature, but not in South Africa. I know the rest of the world doesn't share that joyous occasion with us. So you guys in the outside world, you'll be fine. Cost, they aren't cheap. Surprisingly, the filaments are cheap, but getting going on the printers, again, my 3D printers, on standard 3D printers, I've got custom extruders on them. I'm using the BL Touch bed leveling system. I've got my own, well, not my own, but I'm running custom firmware on the devices. All stuff that makes my life a little bit easier to get the prints going and to get prints through. That can add up. For most people, I would say buying a printer like the Ender 3 will be fine. I've hardly ever, I can quantify my answer here. I've hardly ever needed a bigger print bed than 250 by 250 millimeters, and that's including, just excuse me for 1 second. So that's including printing this behemoth, which is a full working model jet motor, and it's as you can see, it's quite an involved print, and this was printed on my Ender 3. So you really don't, as a start out, really need to go bigger. I haven't had any need to go bigger yet. I haven't had to print anything where I was required to go for bigger print, or to have a bigger print surface. So do you need to go bigger than a standard entry level printer? No, you don't. You're never going to use that much space. The only thing I ever had a slight issue with was the radio plate for the Spitfires, but you can adjust your positioning on your print bed using the slicing software, and you can tell it where you want to put it, and that helps you center it so that you don't have print issues. But that's about it. That's about the biggest thing I've ever had an issue with initially, but it wasn't a showstopper. It wasn't something that stopped me from printing. So no, you really don't need to go for these massive cube printers. Not for a hobbyist, not for somebody that's busy restoring a car. Actually, if you're busy restoring a car and you need parts 3D printed, I'd rather contact somebody that does 3D printing, tell them what you need or send drawings and get them to 3D print it for you. The cost of setting up a 3D printer, the time it's going to take you to learn how to use it, doesn't justify just doing one project with a 3D printer, in my opinion. If you want to get a 3D printer and you want to learn it and then do your project, by all means, go for it. I mean, that's nothing stops you. It's your decision at the end of the day. How long my 3D prints will last in a restoration, that's entirely up to be seen. I've got 3D prints that's been in my car. The TR7, I redid the interior on the TR7 3 years ago, and that's still going strong, and that's parked out in the sun most of the time because I've got customer cars in the carports. So those prints have been holding up fine. If it's PETG, it's not even ABS. So no, I don't think there's ever going to be an issue with it. Maybe down the line, but so far nothing. On that topic, using TPU, I've actually printed seals that I'm busy testing on a Triumph PI fuel injection system. So on the metering unit, the 6 seals that feeds the injectors, as well as the O-ring between the casings and the O-rings on the drive shaft. I've 3D printed seals specifically to test. So far that test is going fantastically well. TPU is chemically resistant, it is heat resistant to a large degree, and that brings me up to my next point. Certain plastics like ABS and like TPU are, I'm trying to remember what the word is because I practiced it and now I can't remember what it is. I think it's hygroscopic. Basically what it means is these plastics absorb moisture when it's in contact with air. After it's printed, it's not an issue. It can absorb moisture. It's not going to deform, it's not going to fall apart or anything like that. Where the problem with hygroscopic plastics like TPU and ABS comes in is during the printing phase. When the plastic heats up, remember this heat up and cool down happens very quickly. So what happens is it heats up in the in the hot end, and when it ejects out the nozzle, that steam effectively inside the plastic expands rapidly and you print bubbles in your plastic, so you get a very rough, unfinished looking surface, almost like when you melt nylon. So if you do print with those things, you do need to look at getting a dryer. Depending on where you are, whether you're coastal or inland, you do need a dryer if you're on a coastal site for PETG as well. Up in Joburg and those places, center, well, what do you want to call it, central cities, no, dryer isn't necessary for those plastics, but definitely for ABS and for DPU. What else can I say? I actually think I've said what I had to say. Oh, just wanted to say thank you to anybody and everybody that commented and gave us advice. Thank you very much for your input. It's your input that helps us build better, build a better channel, and give you the information that you need and want. With tonight's topic, if there's anything that you would like to know more, if there's any other information that you would like to know, please reach out. Leave us a comment. We do look at our comments, and we do answer our comments. Sometimes it takes a little bit, but we do answer our comments. And yeah, please feel free to contact us if you have any questions regarding 3D printing on classic cars, or what can and can't be done. If you've got any other questions, leave them in the comments. We might even do a follow-up episode on this one. But anyway, guys, thank you for joining us tonight. Please remember to hit the like and subscribe buttons and the notification bell. I know it sounds like a nag, but it does help us a lot. It does help us build a better experience for you, and build better entertainment value for you. So please, if you don't mind, like and subscribe to our channel. And thank you for joining us. Have a good one. Cheers.